So then we will focus on this IC current. So if the switch change to here, what is I? I is 0, right? Because this is open, then I is 0. If our switch connect here, then we have I. So what is I? I equal to D multiplied by 0 plus D prime multiplied by I. So it is D prime I. So this is this current. So IC equal to IR. So IC equal to, we have to say IC plus IR plus I equal to what? IC plus IR plus I equal to what? 0. Because this is one point. From this point, total current is what? 0. This is basic ideal. So it is 0. So if you have current go here, current go here, current go here, then summation is 0. So how about I? How about IC? IC is minus IR minus IO. So IC is minus I minus IR. However, I is not always current. If the switch go here, then I is 0, right? So only the switch connect here, we can have a current. So this I should be multiplied by D prime. So now we can say what? IC is CdV CdT. It is equal to minus D prime IT minus IR. So you can see minus IR minus IT prime. So we can say this is minus D prime IT minus V divided by R. So IR is V divided by R. So then what can we do? Did you remember? This is C dV dt. So we can write down C dV. What is V? V includes two parts, DC and small signal, right? So output voltage. What is output voltage? Like this. So it includes DC value and small signal, right? So no problem. C dV dt. Then how about this one? Minus D. What is D? D prime. What is D prime? Anybody still remember? We just erased it. So D prime plus D equal to 1, right? So what is D? D is D plus D hat. So D prime plus D equal to 1. Then we want to compute D prime 1 minus D hat. So D prime minus D hat, right? So 1 minus D equal to D prime. So we can write down this way. And D prime equal to what? D prime minus D hat. So this is D prime. Multiple by what? I. This is minus. Multiple by I. What is I? I plus I hat. This is I. Minus VR. What is VR? V is V plus V hat. and write down this way. And again, we can see in the left side how many items? 2 items. C, D, V, D, T, first item, right? How about the second item? D, C, D, V, F, D, T, right? Second item. So, do we have any question? D, A plus B, dt is equal to dA dt plus dB dt, correct? So we can separate into 2 parts equal to this one. So first is dc. So how about dc? Minus here, this is dc, this is dc, this is first item. This is dc, this is dc, minus VR. So dc includes how many items? This one and this one. Anything else? No, right? How about first order? Anybody can suggest how many first order? This is dc, this is small singular. So we call this is what? First order. So how can you write down? Minus d prime I hat. This is first item. This is small singular. This is constant. So this is first order. First order. This is constant. This is small singular. So this is first order. How can we say this? I, D, prime. And this is minus, minus, become plus. Okay, so this is first order. This is DC. And then second order. Where is second order? Small, small, become square, right? So this is D head I. Minus, minus become plus. So we call this is second order. In here, where is second order? 0. So now, DC equal to DC. So C dV dt equal to minus d prime I minus VR. So this is DC value. So this is DC value. How about first order? Here. First order. So anybody can tell me where is first order? Here. Here. C dV N dt. This is first order. Constant first order. So first order. How about here? Minus d prime I hat minus V hat R plus I d hat. So 3 items. 3 items. And the second order equal to 0. So this is what we need. Second step. So how many equations do we have? We have inductor voltage. We have capacitor current. And we can have relationship to show the first order. So here is the first order. Here is the first order. So how many equations do we have? 2 equations, right? 2 equations. So how about another one? So now I develop 2 equations. One is capacitor current. Another is inductor voltage. And then now I want to develop input current. So finally, input current, we have IG is equal to DC plus AC, right? So for this current, we have DC and AC. So how about this current? Anybody can tell me, how can we describe this current? This current should be equal to QT multiplied by what? IL, right? QT multiplied by IL. Okay. What is QT? QT includes DC QT and the small singular QT, right? How about I? Not IL. I. This is I. So this is I. So I is here. IG. I. So how about this item? This item. This item is total. Total include DC and AC. So we can do math. DI is DC value. So this is DC. How about first order? ID hat. How about first order? DI hat. How about second order? D hat. I hat. So this is first order. This is second order. In here, what is second order? 0, right? So from here, what can you do? You can say my DC bias IG is equal to what? Equal to this QT multiplied by this DC current. So we can say it is DI. So this item. So this is DC value or DC bias. How about the first order? First order we have IG hat equal to 1, 2. So DI hat plus ID hat. How about the second order? D hat, I hat equal to 0. Right? So we have DC value, we have first order, we have second order. But what we need is only first order. So we have this equation. So can you show me how many equations do we have? 3 equations. So can you remember the 3 equations? So I will rewrite again, and we can easily summarize. So we have 3 equations. IG hat equal to DI hat plus ID hat. This is the third equation. How about the second equation? The second equation is here. So second equation, CdV hat dt equal to minus d prime I hat t. So this one, and then minus V hat divided by R, this one, and plus ID hat. So this is second equation. How about the first equation? LDI hat dt equal to dVg plus d prime V hat plus Vg minus V d hat. So this is first equation. So how many equations do we have? 3 equations, right? So now we use the DC bias and the small signal, and we receive the 3 equations. So what can you do? from the three equations, we want to draw the circle, the small circular circle. So how can we draw this circle? So now we have three equations. Okay, we want to draw the circle. So how can we do this? So we will try to do it. First equation from equation start this equation. What can we do? We have dVg. So we have dVg. This is first item. And then we have L di dt. This is L di dt. And then this is plus, this is minus. So dVg equal to L di dt. And we can say dVg equal to L di dt. And then we have to move this one to this side, right? And it become what? Negative. So this is negative d prime dt. This is negative dg minus v dk. Okay. So dVg equal to what? L di dt. Then what about next one? Minus, plus, and this is what? This is Vg minus V dk. And then next one, minus, plus, d prime Vt. So you can see dVg equal to L di dt minus Vg minus Vt hat minus d prime V hat. So this is equal to first equation, right? So we draw the first equation. So this is come from start. If you can draw this, can you draw second start? So I try to save the space. This is first circle. So now we from double start. This one. From double start, what can we do? We have this one. We have d prime I hat t. D prime I hat t. So we move this one to this side. D prime I hat t equal to what? Equal to this one. So how can we do this? This one equal to I d hat plus C dV hat dt plus V hat R. So you can see if we move this side, then this one, let me check. Oh. This is, if we keep this one, let me check. How can we write down this? First, we have to move this to this side, and we keep this one. So this one is this one. This one, we move here. Let me check. The second one. So I draw the circle first. So we have I d hat. We have C dV dt. and we have R. So if we call this one, it is positive. We call this one, it is negative. Minus d prime I equal to what? So this one minus d. Okay. If we move, if we keep this one, okay. If we keep this one, minus d hat I t equal to what? C dv dt plus v hat r minus I d hat. So now this is minus d prime I equal to minus I d because it goes this way plus C dv dt plus VR, right? So we can draw this equation. So this is second step. How about C? This is second step. C from 3 step. We can draw VG. We can draw IG. And IG include two parts. IDA plus EI. Okay. So this is equal to this. IT equal to PI head plus ID head. This one. So this is 3 step. So how many circles do we have? 3 circles. Do you think they are independent or they are dependent? It seems they are independent, right? So what is the relationship? Can you imagine what is the relationship? Anybody can tell me what is the relationship? What is the first? What is the second? What is the third? So first should be what? VG, right? So how can you find VG? Here. So you have VG head. This is input voltage source. And then what? ID head. We have ID head. And then what? Is what? DI head. DI head. So what is DI head? So you have DI head here. You have VG here. But you have DVG here. So DVG is VG multiplied by QT, right? So you can think this is a transformer. The transformer here is 1 turn. Here is T turn. So the transformer convert 1 turn to T turn. Then what is this voltage? This voltage is DVG. So here. So we have T turn. So what is this voltage? DVG. So this one, it is like a transformer. So DVG is here. Then what? Inductance. We have inductance here. Then what? This one. VG minus VD. So VG minus V divided by DL. This is minus, this is plus. Then what? This one. What is this one? D prime V hat. So I combine this one and this one. So now, what do I combine? I combine this one and the second one, this one. So now I combine two, so we can remove this one. We can remove this one because we already combined two here. How about the third part? This is dV hat. dV hat. So then what can we say? This is dV hat. So we have here dV hat. So this is dV hat. Then this is d prime 1. Then how about this one? This is Vt. This is d prime Vt. This is Vt. Because we have turn ratio d prime to 1. So this is Vt. So what is Vt? Vt is here. So we have two current. This is I D hat. This is C dV dt. This is V hat divided by R. So we copy this one to here. So we can remove this one. So how many circles do we have? 1. What does this mean? We have input voltage. The input voltage is Vg hat, small single. Then the input voltage create I hat, right? And here we get I hat. And then from here we can get output. So it is like this. So what is the relationship between input and output? Anybody has any idea? What is the relationship? Input is here. Output is here. Right? So what is the buck boost? Anybody has any idea? What is the buck boost? Here. Right? Input and output. So what is the relationship? We want to know output divided by input. This is what? Transfer function. So if I say in input we have millivolt ripple, how about the output? If the output is 0.5 millivolt, what is the gain? 0.5. So you can see this is buck boost. So what is buck boost? Very, very complicated. So if you have this circuit, how can you analyze it? Is it possible you direct to get the Vg hat? How about I? How about D? How about I? We don't know. So first, what should we do? We have to determine DC bias. Right? So what is DC bias? This is DC bias. 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 Right? So first we have to determine what? DC bias. Then we can put DC bias value here. Then we can put small singular. Then we can calculate output small singular. So we have two steps. The first step is to determine what? DC bias. The second step is to determine what? AC singular. So it is just like transformer. So do you think this is easy? So So what is buck boost? This is buck boost. Where is the switch? Can you show me? Where is the switch? We don't know, right? We don't know. So it becomes so complicated. So this is the equivalent circuit. So if we use this way, how can we call this modeling? We call this is transfer function modeling. So we only think this is buck boost. What is buck boost? Black box. It is a black box. So what is input? VG hat. What is output? V hat. What is the relationship? V hat divided by VG hat. We call this is transfer function. So transfer function is related to what? DC bias. So then if you try to do thesis or dissertation, after you finish the whole circuit, you want to design controller, and you want to know what is the plan of buck boost. Then this is the plan. So if you learn this, then what can you do? You can feedback. You can design PI controller, and then you can feedback. So if you know the model, what can you do? You can design the controller, right? Controller. So what is the purpose of controller? Because input have 1 millivolt, but output create 0.5 millivolt. I think the output ripple is too huge. So I want to design PI controller to make this is 1 millivolt, this is 1 microvolt. Then I have to design a low pass filter, a controller. So how can you design the controller? Then you have to learn the transfer function. So this is the first method to use the mathematical model to describe the buck boost converter. Do you have another method? We have another method we call what? State space. So what is state space? We have to say x dot equal to ax plus bu, y equal to cx plus eu. So we have a, b, c, d. We call this is state space. So do you think state space is better or transfer function is better? Which one is better? State space. So now I will show you how can we use the state space to design the controller. So please use the PPT. So because the transfer function is too complicated, so I use the blackboard to step by step to explain. And if I use PPT, it could be too quick. So now we will move to the state space of the converter. So now what do we need? We need to control this converter. So what is this converter? Anybody has any idea? We have switch here, we have diode here, we have inductor here, we have capacitor here. So what is this converter? Boost, buck boost, or buck. So this is buck converter. So what is input here? VG. What is output? VO. So what do you need to control? do you need to control input or output? So if you have a cell phone, do you need to control input voltage or output voltage? Output. 6 volt, right? So you hope the ripple is small. So you need to control it. How can you control it? You have to feedback. So you have to say, I need a 6 volt and output, right? So this is my desire. So I have 6 volt desired output. So what do I need? I need a 6 volt. So now I said this is VO. VO star is 6 volt. But can you get 6 volt? No. Maybe you get this voltage. So what did you get? You get 6 volt plus minus 1 millivolt, right? So do you need large ripple or small ripple? Small ripple. How can you get small ripple? And you say, I put 6 volt here. If my output is not 6 volt, then we have error. If this is 6, this is 5.5, then this is 0.5, right? Then we design PI controller to reduce the error. And then we design voltage to duty cycle. Because our output is not voltage, our output, control output is what? Duty cycle, right? So we have to change error into duty cycle. And then we have to design level shift. And then we can control the duty. Because if you say this is error, then if this is 6 volt, this would be 7 volt. Then your error is minus. After PI, this is minus. Can you create minus duty? No. Duty always from 0 to 1. So what should you do? You have to do level shift to make sure duty is from 0 to 1. Duty cannot be negative. However, if your command is 6 volt, but your output is 7 volt, then this is minus 1. Then this duty becomes minus 10. It is impossible. So you have to do level shift. So what should you do? You have to design pulse width modulation. You have to control the duty. So you have a triangular, you have error, and then you have duty cycle. So the system becomes feedback. So we call this is feedback system. So we have command error, and then we have triangular. We want to convert the error into duty cycle. So we use triangular to compare, and then we can obtain the duty cycle. So what is duty cycle? Duty cycle means from 0 to 1. But our error could be positive or negative, right? And our duty cycle is 0 to 1. So we have this relationship. So if our error is 0, what does this mean? Means the duty should be 0.5. So you can see here, if output error is 0, then duty is 0.5. If output error is maximum VP, then duty is 1. So if output is negative VP, then duty is 0. So we have this relationship to show the output signal and the duty. So duty should be from 0 to 1, but the error is from minus VP to VP. So we have to use this relationship to make sure the error from minus VP to VP, but the duty from 0 to 1. So we have to use this relationship. So we call this is level shift. So finally, we obtain VO is duty multiplied by VS. So VO is 0.5, 1 plus V reference VP multiplied by VS. If the error is VP, then duty is 1. If the error is minus VP, then this is minus 1. 1 plus minus 1 becomes 0, then duty is 0. If error is 0, then duty is 0.5. So we use this relationship to convert the error to what? Duty cycle. Duty cycle. So we can have 10 minutes break, and then we will go back to show this math.